Hi friends and welcome back. So, the topics for discussion in this week was disinfection, which we have already discussed. We did talk about the basics of disinfection in the first lecture of the week, and then we discussed about the chlorination process in a bit detail in the second lecture, and in the last lecture we talk about the alternative disinfection processes, which are the ozone and UV. Now we are going to discuss the sludge management aspect, okay, which is also one of the component of that in fact produces during the water treatment. So we will be talking about the drinking water treatment sludge, what is the typical composition, the processing and management of the sludge, then the steps that are usually taken like the dewatering and drying and the thickening process, and then we will be talking about the sludge disposal and reuse. So, to start with, usually the sludge stream, which is basically the solid residuals in drinking water treatment systems, are generated either at screening if screening is being used, but as we discussed earlier that screening is very rarely used. So, like in most cases we do not have screens coming out of at the drinking water treatment plant, and if it does come it will just go to the landfill usually. Then we have the sedimentation or flotation process, whatever we are using. So, like the as we discussed that during clarification or sedimentation process the solids settle at the bottom and then sludge is collected. So, that is the major component of sludge that produces from the conventional treatment systems, the sludge coming through the sedimentation process, and if flotation is being used then it is from the flotation process. We will talk about the flotation briefly in the next class though. Then the solids or solid residuals come from the filter backwash as well, because the microflocs that get retained during the filtration stage, and then when we backwash the filter, the backwash spent or the wash water which is collected contains lot of solids. So, that wash water might be like settled and whatever residue comes, so that is also a component of the sludge, and any additional chemical treatment that produces sludge. So, like if you are using say softening process or some other processes, so they also generate sludge. So, that can also be a component which of the sludge. Okay. So, practically like if you see a treatment system, whether we go for pre-oxidation or pre-chlorination, and then we add coagulant and go for flocculation process, and then the decantation or the sedimentation stage produces sludge which comes to the sludge treatment stage, and after the filtration also. So, the backwash the settled mass in the spent water or the wash water also comes to the sludge stage. So, we will be practically talking about this component in this particular class. Now, in the drinking water treatment systems, majority of sludge is produced from the clarification operation, okay, which rely either on settling or dissolved air flotation, but sometimes the direct filtration through a granular media. So, then it will mostly be coming into the backwash of the filter. Okay. The average sludge production is approximately 0.1 to 3% volume by volume of the raw water throughput. So, whatever raw water is fed to a system or drinking water treatment system, almost 0.1 to 3% of the water comes out as a sludge. Now, water comes out as sludge means because we are saying because large portion of sludge is in fact water, the solid content in the sludge are limited. Okay. So, the volume of the sludge generated, that will depend on the plant production, how much amount how much amount of water the plant is handling, then amount of coagulant or other treatment chemicals added. So, like if you are using iron, alum or lime, so how much chemical we are adding, because all that eventually settles and appears as a sludge. Okay. And the amount of suspended solid present in the source water. So, if there are a lot of suspended solids, we are going to get more amount of sludge. If there are limited volume of suspended solids, limited concentration of suspended solids, so then relatively less sludge will be produced. The specific gravity of the bulk sludge that we get is typically reported between 1.002 to 1.06, and the water content is also very high. Okay. So, the solid content typically are very poor, 0.5 to 2% solids, and rest is predominantly water, and that leads the lesser bulk density, whereas the density of solids or the specific gravity of solids are higher than 2. Okay. In some cases even the bulk density is also reported as high as 1.3, but that is rare cases. Generally it is between 1.002 to 1.06. Okay. The backwash residuals are also very dilute because less amount is trapped in the filter. Filter already receives water which are clarified earlier. So, less amount of water, less amount of this particulate or the microflux are retained on the filter, and when we backwash with a relatively large volume of water, of course it is not that large, but in comparison to whatever is trapped, so that results in low concentration. So, around 50 to 400 milligram per liter suspended solids come in the backwash water. So, if we see the typical chemical coagulation sludge volume that is being produced, this is basically from the US EPA. So, depending on the range of the population serves, the average plant flow, the water treatment plant design. So, if water treatment plant is designed say for these flows, okay, this is in MGD, million gallon per liter, million gallons per day. Okay. So, typically the average sludge volume in gallons per day is this much. So, as per US EPA we can convert gallons to liter. Okay. The sludge which is produced, the composition varies on several factors. Okay. It varies on what type of sediments are present in the water, what type of chemicals we are adding. Okay. And then because essentially the composition of the sludge and particularly the dry solids present in the sludge or solid fraction of the sludge will depend eventually on what we are adding, that is what is going to come. Okay. So, sludge will be mainly containing the precipitated chemical additives, whatever coagulant or flocculant we are adding, and the removed contaminants. So, whatever the nature of the solids present in the water, they will get precipitated or they will get removed through the precipitation process or through the settlement process. So, they come as a sludge. So, water treatment sludge typically comprise these naturally occurring colloid and other particulate matter like silt, clay, algae. It will be having some dissolved natural organic matter, humic acids and fluvic acids. It will have some precipitated water treatment chemicals. So, alum or iron hydroxide, whatever we are adding, if lime we are adding, some polymers we are adding. So, it will have all these compounds. It may have oxidized precipitates of inorganic species dissolved in the raw water like iron and manganese precipitates. Okay. And it may have filter media because sand might also some part of sand might get flushed out during the process of backwashing. So, it may contain the filter media as well. So, these are the major constituents of the sludge. Of course, the concentration depends on the initial characteristic of the water, the amount of chemical that are being added. So, the concentration will vary based on those, but composition wise it is going to have those compounds. Now, the sludge that is generated is basically processed through thickening, dewatering or drying stages. Okay. Generally through thickening and dewatering stages, it needs to be dried in fact before it goes to reuse or disposal. So, why that is essential? Because as we were just discussing, the water content is very low, 0.5 to 2%, solid content is very low, 0.5 to 2%, water content is very high. So, it is practically a liquid. So, that needs to be like, if you want to handle that as a solid waste or convert it to a solid material. So, we need to dewater that, we need to increase the solid content and reduce the water content in the sludge. So, for that purpose we use thickening, dewatering or drying processes. So, sludge thickening is basically the process in which the solid concentrations are increased, and this is increased to a range of around 3 to 5%, okay, solid content. So, earlier like we just said that it is in the range of 0.5 to 2, now we increase that in the range of 3 to 5% range. But this 3 to 5% range increase in the solid reduces the water volume substantially. Okay. So, it will be basically decreasing the total sludge volume, but sludge will still behave like a liquid, because in order to for sludge to behave as a solid, the water the solid content has to be increased by around 15 to 20%. Okay. But it is still in the 3 to 5% range, so it still behaves like liquid. So, the next step generally which is followed is the sludge dewatering. We further try to concentrate that, and in the dewatering process we aim that liquids and solid phase are separated to the least possible residual moisture in the solid phase and lowest possible solid particles in the liquid phase. So, we want to like when we are separating, when we are phasing out liquid and solid separately, so we want minimum solid to go in the liquid channel and we want minimum liquid to come in the solid medium. Okay. So, the moisture content in the solid we want less, and the solid content in the liquid or the drainage which is coming out we want again that also we want minimum. So, because of their low solid content, these conventional water treatment sludge are difficult to dewater. In case of lime softening process is used, this softened lime sludge is in fact better to dewater. It has solid content ranging from 2 to 15%. So, it is easier to dewater and generally compact than the coagulation sludge. But conventional water treatment, which basically the sludge coming from the coagulation flocculation process, it is rather more difficult to dewater because of the nature of the sludge, and the specific gravity is also not that high. So, there are a variety of devices which are used for this purpose, for the thickening and dewatering purpose. Okay. So, we have gravity thickeners, gravity belt thickeners, centrifuge, vacuum filters, pressure filters, then lagoons, then sludge drying beds are there. Okay. So, these are there are like several processes. Now, sludge thickening, if you see, so it is basically like we have either gravity thickening or mechanical means of sludge thickening. Okay. So, gravity sedimentation is simply like we put this to a gravity system, we increase the residence time, and that in the top we will see that it is a clear zone, it will actually start settling. So, in the top we will see a clear zone, then there would be some feed zone, and particularly like in the bottom it gets compacted zone, the sludge concentration here is going to be very high, here it is going to be moderate, and top will be actually relatively like very less solid concentration free from this. So, if let us say we are having starting with 1% solid and 99% water, if we are able to increase 5% solid and 95% water, so then we are actually bringing the total volume from 100% to here. So, almost like 80% water will be removed, and the volume of sludge instead of this will just remain this. Okay. So, 1/5, we are increasing the solid content by 5 times, we will be able to reduce the total volume by 5 times. So, we will just have 1/5 of the volume. So, we start with the 1000 liters, okay, and 1% solid content. If you increase the solid content to 5%, the total volume you will be having is just 200 liters, as the 800 liters will be washed off. The gravity thickeners are as just we were discussing, it is a simple like settling basin kind of thing. So, we allow the sludge feed to come in and then let that settle, and through the scraper we can collect the thickened suspension or through underflow. Okay. There are flotation thickeners which can also be considered as a gravity only, but here instead of settling at the bottom they float at the top. Okay. So, we like release air through high pressure, so that these bubbles are formed, and then these bubbles will get stick to the sludge particle, and they will make the like entire bubble and sludge complex will be lighter than the water. The specific gravity will be less because it is attached to the air, and then for that reason it will come at the top, and then from the top it can be skimmed off as a thickened sludge. Okay. So, that is also one of the means. It is more popular though in the wastewater treatment systems. Water treatment sludge is generally not fed to the these kind of thickeners. Gravity thickeners are common, but the like dissolved air flotation or DEF kind of thickness thickener are not that common. In the mechanical thickeners, again we have the gravity belt thickener. Okay, so there is a belt, and by the force it is basically pushed through the belt, so that filtrate comes out. Okay, and thickened sludge passes on through the belt and collected here. So this belt actually keeps on rotating. Okay, and filtrate will be coming at the bottom. So we will feed the sludge here, it will go on the belt, and then belt is processing, it will be pressed. Okay, so that sludge comes out. And then we have screw press thickeners. Again through a screwing system, the sludge is put into the chamber, and then it is basically through a screw it is pressed, and then solid residuals come out. Centrifuge thickener, so basically with the help of the centrifugal force the sludge is rotated, and this centrifugal force allow the sludge particle to settle the center in the concentrate, and then effluent comes as a supernatant. Okay. And then rotary drum thickener, again the sludge is put it in a drum, and that entire drum is rotated, and in the process basically the water drains out and sludge comes. So these are some of the mechanical thickeners. This is not just thickening devices, they are used as a dewatering devices as well. Okay. So mechanical thickeners, at which stage we are using it. Okay. If we are feeding a very raw sludge, it will just thicken to certain percentage. If we are using a more thickened sludge, or recycle that again to the this thickening process, particularly the mechanical thickening process, so we are going to get more like elevated solid concentration. So they can be considered as an option for the dewatering as well. Okay. Generally thickened sludge, or at times even the raw sludge directly, is dewatered, and it can be dewatered either through natural or mechanical dewatering process. So these dewatering processes are also mostly developed for the wastewater industry, but with more or less adjustments they are adopted in the water treatment as well. The natural dewatering operation is typically dewatering or drying operation is typically sludge drying beds. Okay. So sludge is laid out on the bed, and basically this removes water primarily either by evaporation or by drainage. So initially what happens, that the drainage will take the water out through percolation process, and water will evaporate from the top, but there is a limited capacity for water to drain. So drainage will progressively stop, but evaporation still keeps on continuing. So we can get it dried to whatever level we want, but again there are certain issues with natural dewatering operations, like if bad weather is there, if it is a rain event or something happens, then it is going to acquire substantial amount of moisture or water again. Okay. So evaporation is driven by the solar radiation, air, humidity and wind, and drainage is basically through the pull of gravity and capillary suction. So that leads the the water through drainage goes down, and water through evaporation goes to the atmosphere. There are mechanical means of dewatering also, again the centrifuge or various forms of the filtration, filter presses, belt presses or drums. So these are used for dewatering purpose. Then the dewater or dried sludge can be either reused or disposed. Reuse options are there, limited but not that frequently used. So in a reuse terms, it can be reused in a wastewater industry. So research has shown that we can recover the coagulant from the water treatment sludge, okay, and use that, or a basically modified or purified form of a sludge we can use to remove the impurities such as turbidity, BOD, COD and suspended solids, phosphates etc. from wastewater. It can be reused for applications as engineering materials, and particularly the civil engineering domain, and that is one of the by far most common or most popular reuse in terms of reuse in fact. So it can be applied as a raw material to produce the construction supplies. So it can be considered as an ingredient for cement, brick or concrete or kind of lightweight aggregates. The alum based dried sludge essentially forms insoluble rock and are inert like gravel, okay, but it is not that hard or that strong as gravel, it is still light, okay. So it has been used for filling under the road, backfilling beneath the fiberglass swimming pool, then during the bridge construction. So lot of for filling material particularly, this sludge has been very common, okay. So that is one of the like most common reuse, that these sludge, dried sludge is used as a filling material for various civil engineering applications or civil engineering constructions. Then it can be used for agricultural practices or other land based uses. Now this part is very critical because sludge use in agriculture is very common, but that is more suited for wastewater sludge because that is mostly organic nature and helps the soil in it can provide the fertilizers or some other minerals, essential minerals to the soil. But unlike wastewater sludge, residual from water treatment sludges are biologically inert. We do not have too much of like biological substances or organic substances. Okay, the organic content is also very little, so they have very little value as fertilizer or soil conditioner. So they cannot be typically like used as a soil conditioner or fertilizer. Still some people use it, okay, for say pH adjustment, immobilization of the phosphorus in the eutrophic lake systems, and many times pit fillings. Okay, sometimes it is also used for other land based uses, okay, like leveling, if there are some ground, and then even in the some sports ground also for leveling and these purpose these sludge might be used. Okay. Then there are chemical reuse options, so which is basically we recover the chemicals from sludge, like we can recover aluminum sulphate from alum sludge, and this recovery can be quite good, up to extent of around 80% we can recover in fact. Okay. We can recover various metals and salts or ions from the sludge, so that is the another like reuse option. Now if sludge is being reused, it is good, but otherwise in most cases or most places, particularly in the developing countries, the sludge handling is still very casual and only little amount is reused, and majority of the sludge find its way to the environment through the disposal systems. The popular disposal routes, like the way people dispose the sludge, includes the discharge to a natural water body. Now this was popular in the past. Earlier, like majority of the even the like United States treatment facilities, water treatment plants in the United States, they also used to discharge the sludge directly to the natural water bodies like rivers and those systems. But environmental regulations has become quite strong now, and this is no longer considered a viable option. So we do not consider this as a viable option anymore, because it will create lot of problem in the river body in which it is disposed of. The other disposal place is discharging to the sewer. So people might put it in the sewer line, means the utility, water treatment utility at times put it to the sewer line, and then it can be treated together with the sewage treatment sludge at the STPs. Here also, like many times, if it is not discharged directly to the sewer, it is filled in the trucks and brought to the wastewater treatment facility or sewage treatment facility, and then it is processed along with the sewage sludge. It can be discharged to simple lagoons or ponds, but that is generally considered as an interim step, like people put it in the lagoons and then once it gets dry or the lagoons gets filled up, so they transport it to the other site. But some facilities use lagoons as a storage system for considering them as a ultimate disposal. So when there is a no land crisis, they can keep on filling these lagoons. Then there are landfill options. So it goes to the landfills. Dewater sludge is sent to the landfills for long term surface storage. It can be dumped into the landfill and then it is stored there for large times. Again, the leaching and those things needs to be studied when it is going to the landfill sites. Then land application, again disposed to the barren land or agricultural land, means particularly if it is being disposed to agricultural land for some purpose, you can consider that as a reuse option or like beneficial use option, but otherwise many times it is just disposed to the barren lands. So that's a sheer disposal option because it does not have any intended use there where it is being applied. Okay, it's just considered as a like the land is considered as a dump site and the dewater or dried sludge is dumped there. Then there are engineering fill. Okay, again it is basically disposed of as a filling material at civil construction sites, as just we were discussing. So, engineering fill is essentially a beneficial use, although like utility might consider they are dumping this, like let us say for a bridge construction or those things, lot of filling materials are required. Now, or road constructions or various other like large civil structures constructions, dam, road, these things, so lot of filling material is required, and utility might consider that just they are dumping it, but it is actually kind of beneficial use because it is fulfilling the requirement of some filling material. So, that way like these are the disposal options for the sludge. So, we will conclude this discussion on the sludge. This is how the sludge is handled, okay. And generally the sludge is not given the due attention which it should be given. In most cases, like if you see the water treatment schemes, they do not even talk much about the sludge processing, but in conventional system the collected sludge is thickened, then dewatered or dried by putting through the sludge drying beds, and then it is usually disposed of to some landfill site or open dumping. That is what is commonly done with at most places with the solid residues in the that come from the drinking water treatment facilities. So, we are concluding this discussion here, and now in the next class we will start talking about the advanced treatment options. So, thank you for joining, and see you in the next class.